students can add variables to stack frames, directly add and edit the values of those variables. For primitives, the values are added and edited directly through typing on the keyboard. For object values, the heap can be modified by adding and creating objects, and pointers can be dragged from value boxes to the objects to represent those pointers. Frames can be added as well. Their names and parent notations can be modified. For lists, elements can be added using the various buttons there. Additionally, if there are extra elements that exist, they can be deleted. The same is true of extra variables on stack frames or extra stack frames. Once the problem is done, the student can save and grade their answer. They can see their score based on the configuration that the instructor provides in Prairie Learn. Here we can see that the student has made an error, so they correct their error, and they resubmit the problem to see their new grade. The presence of the correct answer can be configured by the instructor. All aspects of the input system are navigable by the keyboard using tabs, and students can report an issue with the question using the built-in features of Prairie Learn if they notice something is wrong. They can also request a new variant of the problem, which is randomized. Instructors can also see a JSON version of the correct solution for debugging purposes.
So let's say you like this tool, you want to make a question for your own students. How do we do that? And to begin, we are not going to be giving a tutorial on how to use Docker and Prairie Learn in this video, but that information is included in our wiki, and you can see links there for how to set up Docker and Prairie Learn. This is assuming you have everything set up and you just want to start making a problem. So first, let's make a copy of one of the existing problems to make our own new problem. Let's look in the info.json file. So this has a bunch of information. It has the UUID, which is the ID of our problem. It should be unique. You should generate it. I'm just going to replace one character because I'm being lazy for a demo. For the title, let's replace it with the title of what you want the problem to be. Topic is going to be environment diagrams, or you can rename it to what you call it in your class. Single variant is whether or not you want to randomize. Keep it false if you do want to randomize. And partial credit, whether you not want to offer partial credit. So now let's look at question.html. This is where the question is set up. Here you can see the question description, so explaining to the student what they're going to be doing. Then there's params.codestring. So that's the actual code string that your students are going to be seeing. Here we're opening up where that's actually calculated. It's in data params code string is where it's assigned. The function that comes after is the function with our randomization settings that we offer to you to modify. If you want to replace it with your own function, with your own randomization functions, that is completely fine and you can do that. If that's what you want to do, you can skip on to the next part of the video. Now we'll be going into how to use the randomization settings that we offer. So the main file you'll be editing here is qgencustomization.py. This has copious instructions for how to do each of these things, but we'll go over them via voice. The first thing that you'll want to do, whether you want to randomize your code or not, is modify the code string to be the default code string that students are going to see or is going to be randomized from to generate new code strings. So here I'm making a new code string. I'm just putting in some simple functions and assignments. Maybe instead of a code string, you'd rather put it in a file. So here I'm making a new file called new Q. I can put the code there and then make a code file path new Q. And then once I've done that, it will use the file instead of the code string that I provided. So after we've written our code string, we have a few options for randomization. First is changing the variable names. So here we have A, B, and F as the variable names in our code string. I can change the options that it'll choose from. So question gen dot, we have a bunch of different functions that will generate things like lowercase letters. You can see the options at question gen.py. For example, let's say for A, I don't actually want that, and I want the options to be X, Y, and Z. I can just write it as a list. Alternatively, in B, I just want it to generate from that function. I'm going to put it there. And then F, I'm okay with it doing common function names or all of these options. The it will pick a random item in the list. If it's a function, it will generate a replacement from that function. If it's not a function, it will just use the item as a replacement. So the next randomization option is assignment values. So on each line, when there's an assignment, an equal sign, we want to change what's happening after the equal sign. So here it's by line number, so that starts from line 0, then on to 1 and 2. We're going to change lines 0 and 2. Great. Okay, so now on to the next option, special replacement. So special replacements are, let's say I want to replace something that isn't covered by the first two. Here I can replace any string with another string. It's a simple regex replacement. So we want to put something that is unlikely to appear in Python, such as $1, and then put what we'd want to replace there. So we could have it be return, or we could have it be lambda a. So we get two different potential options. I don't want to do that here, so I'm going to delete it, but that's an option you can have. You can also do this in the code file. If you're doing it in a file instead of a code string, you would do the same thing. You would just put whatever you want the string to be replaced there. It's going to error. That's fine. It'll still work. Great. So now I want to test everything I've written, see if it randomizes properly or it causes errors. I can just run this file, press the play button at the top. Oh, so it seems like we had an error. Now we can try to bug fix. This is why we do it here before in query learn, so we can see if there's an issue before having to compile everything there. It looks like I should have put quotation marks around each of the numbers after 2, so I'm going to do that. And I'm going to try running it again. Let's see what happens. So I run it again. That looks normal. I'm going to run it a few times to make sure that none of the randomization options cause problems. Now I've run it a few times. I want to try it in query learn, see if it causes any issues there, see if everything runs smoothly. So we're going to do that in the next part.
Once the instructor has configured the source files and made sure that everything is saved, the question can be demoed in Prairie Learn. The question needs to be reloaded from the disk so that it can be seen. There we can see the new question, which, as we can see, has been randomized according to the parameters set by the instructor. The student can complete the question in much the same way they've completed any other question, and then they can save and grade it to get their score. We'll now describe a few ways of modifying the grading parameters beyond randomization, and these two parameters are granularity and tolerance. Granularity describes the number of discrete grading steps that there are. A granularity of 2 indicates that the problem should be graded as all or nothing, while a granularity of 10 indicates that the student's score should be rounded to the nearest 10%. Lower granularity makes guessing and checking as the student more difficult. So here we will set the granularity to be 3. Then we'll save the source files and reload the question from disk. And we will complete the question to the same extent that we saw before. As we can see now, the student's score is 33%. It's been rounded to the nearest third, and it rounds down. Now, tolerance is a setting that affects the harshness and speed of grading. You can think of the tolerance as essentially the number of errors that a student gets before they lose all partial credit. By default, the tolerance is set to be equal to the edit distance between an empty diagram and the correct diagram. A higher tolerance means more lenient grading, but is also more computationally intensive. So here we will set the tolerance to be 4, which is quite low given the complexity of the diagram. We'll reload it and again complete the diagram to the same extent that we completed it before. Save and grade it. And we can see that the student has now lost all credit for the problem because the tolerance was set very low.